So this is on basic exponents and logs, so we'll see a lot of exponent rules here. There's a couple different ways I can deal with the first one. I'm just going to distribute the squared though, because we can distribute exponents over division, which is what a fraction is. So 1 squared is 1, and x to the third squared, we multiply exponents with power to a power, so that's x to the sixth. Now I don't see that answer, but I know if I have division, that's equivalent to having a negative exponent without the division, so that's number 4. This is technically the simplified answer, but this is one that's equivalent, that's a multiple choice. The next one has a negative exponent and a fractional exponent. So just as a review, the negative means we need a fraction. So that means this is 1 over x to the 1/4, or really I should say the negative exponent means we have division by what we have with the exponent. The top number is the power, the bottom number is the root. So this is 1 over the 4th root of x to the first. We don't really need the first, and we see that choice 3 is correct. The next one, we're simplifying a cube root. So we need to, for the number, the 135, think of power, or we need to think of perfect cubes. So for 135, I'm trying to see, does 2 cubed, which is 8, go into it? 3 cubed, which is 27, 4 cubed, which is 64, or 5 cubed, which is 125. So if I tried this out on a calculator, 27 does go into 135. 27 times 5 is 135. So here, for the number, I'm going to break this up into the cube root of 27 and the cube root of 5. 27 times 5 is 135, so that's a legal move. Now for the variables, I'm going to rewrite them as exponents. So here, I have x to the 4/3 because we put the root below the exponent, and we have y to the 8/3. Now I want to split this up so that I have basically numbers that can be divisible. So I'm going to split up the x to the 4/3 into 3/3 and 1/3. I'm going to split up 8/3 into 6/3 and 2/3. Just because I'm showing this a little bit, a little more in depth, because this is an answer key, I'm going to bring down the numbers and now talk about what to do with the whole thing. So anything I circle is a perfect cube. This is a perfect cube. 3 is divisible by 3, and 6 is divisible by 3. So here we have cube root of 27 is 3, x to the first, y squared. And then everything that I did not circle is going to go back into the cube root. So I have the cube root of 5, x to the first, y squared. Basically, the 3's go away when we put it back into the cube root because I have it in the other form. So looking through my choices, it looks like choice 4 matches up correctly. So the next one, we have 2 functions, p of x and r of x, and they want me to multiply them. So I have a b to the x times 4c to the x. So just reorganizing this, I'm going to put the 4a in the front, and really I'm asking, what do I have to do with this b to the x, c to the x? So I want to think about my power rule. We know if we had bc to the x, that I could distribute the exponent and make it b to the x, c to the x. So this is just working backwards. That doesn't work with addition. We can't distribute exponents over addition. And the exponent doesn't change when I distribute it. So this is the correct answer, the one with that b, c to the x. The next one, we have our roots, but we also see we have division, and that means we can subtract the exponents, but first we have to write things as exponents. So this is going to be written, the power is 5, the root is 2 for the numerator, and the power is 7, the root is 4 for the denominator. So now when I subtract the exponents, I could just do 5/2 minus 7/4 on my calculator. I could also make this an LCD, so that's 10/4. 10/4 minus 7/4 is 3/4. I don't see x to the 3/4, but I do see a root that's equivalent because this is the 4th root of x to the 3rd. So choice 1 is the correct answer. I'll fill in 2 for that one. The last question on this page has an equation to solve. We can make the bases the same, but first I'm going to rewrite 0.5 as 1/2. So 1/2 and 8 are both powers of 2. 1/2 is 2 to the negative 1. 8 is 2 to the third. Now I'm going to bring down the exponents that were already there. So basically here, if a power of 2 is equal to another power of 2, I can cross off the 2's and just solve with the exponents. We do need to distribute because we have binomials in here. So I get negative 3x minus 2 equals 15x, it's a minus sign, minus 4. And yes, that's correct. Okay, so from here, I want to get the x's together and the numbers. So I'm going to add 3x to both sides, and I'm also going to add 4 to both sides, canceling one thing from each side. So now I have a 2 equals 18x. And just checking this for a second, this should have been over here a 12. I'm not going to redo the video, but this should have been a 12 here. 3 times 4. Didn't make it over there. So this would be plus 12. Okay. Negative 2 plus 12 is going to be 10. So I just need to erase this part and make this a 10. So the concept's the same. I just missed a distribution. So then we're going to divide by 18. And both of these are divisible by 2. So I get 5/9 as my final answer.